Hello, my dear students. Welcome to the session. Continuation of important observations from power electronics concepts. In this session, with respect to Module 3, choppers, that is DC to DC converters, I would like to discuss about concept of types of choppers based on commutation, multi-phase choppers, and SMPS concept. All of you concentrate. First, we have to start with the types of choppers based on commutation. Friends, we know that based on commutation, the choppers are classified into voltage commutated chopper, current commutated chopper, load commutated chopper, Morgan chopper, Jones chopper, AC chopper. Mainly, these two choppers are very important for gate exam point of view. This is a voltage commutated chopper. The chopper is also called classical chopper or parallel capacitor commutated chopper, where Tm is the main thyristor, Ta is the auxiliary thyristor. Mainly, you have to concentrate on the formulas. In this circuit, if the auxiliary thyristor is triggered, a reverse voltage is applied across the main thyristor, then main thyristor will be turned off. That's why it is also called parallel capacitor commutated choker. This is very important points. What is the peak current through the main thyristor? I0 plus Vs into square root C by L. That is, main thyristor carries the both load current and capacitor current. What is the peak current through the auxiliary thyristor, students? Peak current through the auxiliary thyristor. The peak current through the auxiliary thyristor equal to I0. What is the peak current through the diode? What is the peak current through the diode? That is IDP equal to Vs into square root C by L. What is the peak instantaneous voltage across the load? The peak instantaneous voltage across the load is nothing but a peak inverse voltage across the freewheeling diode, that equal to 2 Vs. This is very important that you have to concentrate. When the peak voltage will appear across the freewheeling diode or load, whenever the auxiliary thyristor is triggered, then only a peak voltage will appear across the load. Peak voltage across the load is nothing but a peak inverse voltage across the diode. Then what is the circuit turn-off time? Based on this formula, GATE 2024 question is framed. The circuit turn-off time TC equal to CVS by I0. CVS by I0. What is the average output voltage, friends? The average output voltage D dash into Vs, not D into Vs. It is a D dash into Vs. D dash or alpha dash. Some authors they are using the alpha is the notation. Some authors they are using the D is the notation. Both are. Alpha is the duty cycle. D dash is also. D is also duty cycle. But what is D dash name is given? Effective duty cycle. What is the effective duty cycle? T on dash by T square. Very important formula to calculate average output voltage. Then what is the effective on period? Effective on period equal to T1 plus 2Tc. What is the T1 here? That is the minimum on period of the main thyristor, that is pi root LC. Very important formulas. Minimum on period of the main thyristor, that is pi root LC. Then what is the disadvantages of voltage commutated chopper? Starting circuit is required. Peak inverse voltage across the freewheeling diode is 2 Vs, which increases the rating of the freewheeling diode. It cannot work at no load condition. Main thyristor carries the both load current and capacitor current. That is, it carrying the high current. Once it carries the high current, the cost of the thyristor is increases. High rating thyristors are required. There is a possibility of commutation failure in the case of voltage commutated chopper. Then this is the current commutated chopper. A current commutated chopper. This chopper is also called resonant pulse commutated chopper. Resonant pulse commutated chopper. If the capacitor current is supplied by, if the load current is supplied by capacitor, if the load current is supplied by the capacitor, then main thyristor is turned off. Main thyristor is turned off. This is called current commutation. What is the peak current through the main thyristor? These formulas are very important. In the case of current commutated chopper, the peak current through the main thyristor equal to I0. What is the auxiliary current through the, what is the peak current through the auxiliary thyristor? Not auxiliary current, peak current through the auxiliary thyristor. Vs into square root C by L. What is the peak current through the D2 diode? The peak current through the D2 diode is Vs into square root C by L. This is the D2 diode. This anti-parallel diode, even in voltage commutated chopper also we have to use, but mainly this is important. What is the peak current through the D2 diode? Vs into square root C by L or I0? I0 given, that is correct, or Vs into anyone they will give. Both they don't give. Either load current they will give or Vs into square root C by L. Then what is the peak voltage across the capacitor, friends? That is, in this chopper the capacitor is overcharging, because whatever the energy stored in the inductor that is delivered to the capacitor, that's why capacitor is overcharging, because of energy is transferred from inductor to capacitor. Next, what is the circuit turn-off time? The circuit turn-off time Tc equal to pi minus theta by omega naught. Pi minus theta by omega naught. Then how to calculate the theta, students? Theta equal to sine inverse 1 by x. How to calculate the x? ICP by I0. How to calculate ICP? Vs into square root C by L. This is very important observation. 5-star formula. Circuit turn off time, we can expect your exam. Commutating inductor formula. Still now based on inductor capacitor design formulas, no questions in GATE exam, but already questions are framed in ESC exam. The commutating inductor L equal to Vs into Tc by x into I naught into pi minus 2 into sin inverse 1 by x. For the commutating capacitor formula, students, the commutating capacitor formula is x I naught into Tc by Vs into pi minus 2 into sin inverse 1 by x. This is the commutating capacitor formula. Then this is the load commutated chopper. Up to now I discussed about voltage commutated chopper and current commutated chopper. One more chopper is the load commutated chopper. In load commutated chopper, there is no any inductor. It requires only capacitor. Important observation. In which commutated chopper? In which commutated chopper? Only capacitor is required. Inductor is not required. Only load commutated chopper. When the inductor is not present, this noise is very less. In load commutated chopper, the noise is very less because there is no any inductor swing. And these formulas mainly you have to remember with respect to load commutated chopper. For the average output current, what the capacitor formula, for the average output voltage formula, that you have to concentrate. This is the average output voltage formula you can write. What is the T on time equal to 2C Vs by I naught. Then T minima equal to T minima equal to T on, that you have to remember. Then what is the maximum frequency of operation? 1 by T minima. And this is the capacitor formula that you have to remember. This is the circuit turn off time. Very important, students. Circuit turn off time equal CVS by naught. Then it total commutation interval equal to TC. In this chopper also peak inverse voltage across the load. Sorry, peak inverse voltage across the freewheeling diode or peak instantaneous voltage across the load is 2 Vs. And these are the merits of the load commutated chopper. It is capable of commutating any amount of load current. No commutating inductor is required, that normally less costly, less bulky and less noisy. And it can work at frequencies in order of kilohertz. Filtering requirements are minimal, students. But these are the demerits of the load commutated chopper that you have to concentrate. Mainly voltage commutated chopper and current commutated chopper only important for exam point of view. Just Jones chopper also you have to concentrate, just 1 or 2 points only. The Jones chopper is the voltage commutated chopper. That is, in this chopper, voltage commutation is used. Jones commutation is the voltage commutation. But instead of inductor, a center tap transformer is used. This is important, students. That is, which chopper consists of center tap transformer? Jones chopper consists of center tap transformer. That you have to consider. Why center tap transformer is used? For effectively turn off of the main thyristor. Next, Morgan chopper. In Morgan chopper, current commutation is used. In Morgan chopper, it does not consist of auxiliary thyristor. It consists of only one thyristor. This is the one feature of the Morgan chopper. Remaining choppers, there is a 2 thyristors, 3, 4 like that. But in the Morgan chopper, only one thyristor, and it consists of saturable reactor, students. Very important. In which chopper there exists a saturable reactor? Morgan chopper consists of the saturable reactor. It does not consist of the auxiliary thyristor. Instead of inductor, a saturable reactor is used. Next, AC chopper. But with respect to AC chopper, T1, T2 are the main thyristor, T3, T4 are the auxiliary thyristor. To turn off T1, T3 is useful. To turn off T2, T4 is useful, student. Mainly for AC chopper, it is used as a AC switch. We can control output as a AC only. Even though it is a chopper, why the name is given as a AC chopper, we can control our output side as a AC. That's why it is AC chopper is used as a AC static switch only. And this problem you have to practice, students. Very important. It is the LC circuit is given. What the current? It is instantaneous current. You know this instantaneous current formula, no? V naught into square root of C by L into sine of 1 by root LC into T. In the module 1, in the explanation of commutation methods, I solve this problem. Once again, it is repeated here. That you have to practice, students. Problems are very important. In this concept, types of choppers based on commutation, maximum numericals we can expect, students. Very, very important. And this also you have to concentrate. This is the chopper. Which chopper? This one. This is the voltage commutated chopper. Voltage commutated chopper, students. How to identify, is it a voltage commutated chopper or current commutated chopper? Simply remember, here if the diode is present, that is a current commutated chopper. If the diode is not present here, it is a voltage commutated chopper. Like that you have to remember, students. In a voltage commutated chopper, what the peak current through the S1 switch? Here S1 switch is nothing but a main thyristor. S1 switch is the main thyristor switch. What the peak current through the main switch, that equal main thyristor I naught into Vs into square root C by L, that is 40 amperes we can get. Here it is asking that what the minimum on period of main SCR. This is also which one? Voltage commutated chopper. In voltage commutated chopper, what the minimum on period, that equal to pi root LC. Based on this also gate question is there. What is the minimum on period of the main thyristor students? That is pi root LC. Pi root LC. That is pi into root LC, that you have to take 140 microseconds. In voltage commutated chopper, what is the half time of the auxiliary thyristor? Half time of T of auxiliary thyristor students. This is also important. Auxiliary thyristor. The half time of the auxiliary thyristor equal to pi by 2 into root LC. Pi by 2 into root LC. This also you have to remember. Then in the above problem, calculate the average output voltage. What is the average output voltage formula? V naught equal to D dash into Vs. What is the D dash I given? T on dash by T. What is the T on dash? That is T1 plus 2 Tc. What is the T1 I calculated the minimum on period. 2 into Tc. Tc is what is the formula? CVS by I naught. Tc circuit turn off time formula is which one, sir? This is the main SCR turn off time or circuit turn off time. Where Tc equal to circuit turn off time. Circuit turn off time or main SCR turn off time. Main SCR turn off time. Both are same here. That you have to remember. That is how much here? CVS by I naught. CVS by I naught. Once you T on dash is calculated, you can calculate average output voltage equal T on dash by T into Vs. This is voltage commutated chopper. If any question is framed like this is the question based on the current commutated. How to identify this chopper is current commutated based on this diode. It is a current commutated chopper. What the peak current to the main SCR? That is I naught. I naught how much it is given? 10 ampere. What the peak current through the auxiliary SCR? Vs into square root C by L. Like this you have to calculate for. This is which chopper? Current commutated chopper. Then one more important concept is the multi-phase choppers. Multi-phase choppers. At this point, no need to concentrate. In multi-phase chopper, this is called two-phase chopper. What do you mean by multi-phase chopper? If the choppers are connected in parallel, that is nothing but a multi-phase chopper to meet the high current demands. See, if the two choppers are connected in parallel, that is called two-phase chopper. If three choppers are connected in parallel, that is called three-phase chopper. In parallel connection, voltages are equal, sir. Voltages are equal. For this chopper and this chopper, voltage is equal. But only current is added. Current is added. In multi-phase choppers, current is added. But is the currents are added or not added? Again, that depends on the operation of the chopper. This is called in-phase operation mode. In in-phase operation mode, what do you mean by in-phase operation mode? Both the choppers on and off at the same instant. At this instant, chopper 1 is on, chopper 2 is also on. At this instant, chopper 1 is off, chopper 2 is also off. That is, both the choppers are on at a time and off at a time. That is called in-phase operation mode, student. In in-phase operation mode, currents are added. This is I naught, this is I naught, na. Then it becomes 2 I naught. That is called in-phase operation mode. Next, what do you mean by phase shifted operation mode? In phase shifted operation mode, the on and off state of the choppers are different. Chopper 1 is on at this instant, but chopper 2 is on at this instant. Chopper 1 is on at this instant. Chopper 1 is off here. Chopper 2 is off here. That is on and off of the choppers are at a different instant. If on and off of the chopper is at the same instant, that is called in-phase operation. In in-phase operation, currents are added. In phase shifted operation, currents are not added. That remains constant. If you on like this, that current remains constant only. Voltage is also equal. Current also remains constant. But here frequency is controlled. That is frequency in the sense chopping frequency, not the supply frequency. Because input is DC, output is DC. Where is the supply frequency, sir? Here switching frequency is controlled. This is a question based on multi-phase chopper that you have to concentrate. In this chopper, it is asking that what is the each switch current. It is asking IS1 and IS2. V naught equal to dVs. I calculated I naught equal to 50 amperes I got. But in this duty cycle not given directly, from this waveform you have to calculate the duty cycle, students. On time by total time period. Now on time 5 milliseconds, total time period 1 millisecond. I got the duty cycle equal to 0.5. Once you know the duty cycle, I got then you have to calculate, assume that lossless chopper input power equal to output power. If input power equal to output power, I got the source current equal to 25 amperes. Let us assume that both the choppers are same type of chopper. If there is a same type of chopper, both the switch currents are equal, then IS1 equal to equally divided. The currents are equally divided. Both the switch current is equally divided. Assume that the type of choppers are same type of chopper. If it is the same type of chopper, the switch currents are equally divided. Total current I got 25 amperes. Each switch current is by 2 you have to do. That is 12.5 amperes. Then these observations also you have to remember. Not that much of important, mainly for gate point of view, ESC point of view it is important. Then this a DC to DC converter, there is a without isolation, with isolation. With isolation transformer, those are called SMPS. Without isolation, those are called choppers. Both are DC to DC converters. Now, with isolation SMPS, there is a unidirectional excitation, bidirectional excitation converters. Which are the unidirectional excitation converter? Flyback converter, forward converter. Which are the bidirectional excitation converter? Push-pull converter, half-bridge converter, full-bridge converter. Important for theory questions also. There is soft switching converter. Soft switching converters example is resonant converters. All these are the hard switching converters. All these are the hard switching converters. But only soft switching converters are resonant converter. ZVS switching, ZCS switching. That you have to concentrate. These formulas mainly you have to concentrate. What is the difference between the SMPS and chopper? In SMPS, there is a transformer arrangement. With the transformer, the average output voltage of flyback converter Vs into D into 1 minus D by N2 by N1 square. That is, this formula already you know, na? dVs by 1 minus D. Without transformer, without this ratio, dVs by 1 minus D is the which regulator? Buck regulator. Sorry, buck boost regulator. That is up-down chopper, na? dVs by 1 minus D is the which one? Buck boost regulator. That is up-down chopper. That is, it is equivalent to isolated buck boost converter. It is equivalent to isolated buck boost converter. Flyback converter is the isolated buck boost is equivalent to isolated buck boost converter. But N1 by N2 is called the turns ratio of the transformer. Forward converter, what is the average output voltage bands? It is a forward converter. This is isolated buck converter. In buck converter also DVS. Forward converter with transformer, buck converter without transformer. This is push-pull converter average output voltage. Direct formulas you remember, sir. Push-pull converter average output voltage. For half-bridge and full-bridge converter also same formula. Forward converter, half-bridge and full-bridge also same formula you have to apply. These are the formulas with respect to SMPS, that is flyback converter, forward converter and push-pull converter. Push-pull converter. Yes, friends, with this, with respect to module 3, types of choppers based on commutation and SMPS concepts are completed. With this, total module 3 is completed. In module 3, video 1, I explained about buck regulator, boost regulator, buck boost regulator, types of choppers based on the quadrant operation. And practice questions also I given. In this video that I explained types of choppers based on the commutation and SMPS and practice questions also I solved. This is about the session. Thank you.